Hello, 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 Course 3 students. Welcome to a new part of our Chapter 4 here. So we've gone through a lot of different things in this chapter about exponents and square roots and identifying what kind of numbers are what kind of things. Are they rational, irrational? So we're getting into the last two lessons actually here, which are all going to be on triangles now. So now we're kind of changing our focus to something called Pythagorean theorem, and I'm actually super excited about this because this is one of my favorites. It's a theorem that when you get used to it becomes very kind of second nature, and a theorem or an equation that kind of sticks with you as you go through schooling. So we are focusing on triangles, but we're going to still be using our exponents because part of this equation, when we get into it, uses exponents. And so that's why it is still a part of this chapter. So your objective today is I can learn to use the Pythagorean theorem to solve problems. Well, we got to get to what is this Pythagorean theorem and who is Pythagorean or Pythagoras. So Pythagoras, so who this theorem is named after, was born on the Aegean island of Samos sometime between 580 BC and 569 BC. He is best known for the Pythagorean theorem, which relates the side lengths of a right triangle. A Babylonian tablet known as Pimpton 322 provides evidence that the relationship between the side lengths of the right triangle were known as early as 1900 BC. Many people, including U.S. President James Garfield, have written proofs of the Pythagorean theorem. In 1940, E.S. Loomis presented 370 proofs of the theorem in the Pythagorean proposition. So that's a little background history on this theorem, that it's been around for a while. Pythagoras came up with it, but then they're even talking about how some other scientists or, a president, a mathematician have also verified and made sure that this indeed does work. And so that's what they're talking about, those proofs. When you get into geometry, you do things that are called proofs to prove that this is a system in math that works. So then they just say this, they have a little statue here. The statue of Pythagoras is located in Pythagorean Harbor on the island of Samos. So here is what actually is the Pythagorean theorem. So here is the word versions. They've got numbers and they also have algebra. So it says in any right triangle. So the first thing we need is a triangle that has a right, oops, that's not good, is a right triangle. So that means it has a right angle. So it says in any right triangle, the sum of the squares of the lengths of the two sides. So sum meaning addition, and then squares, we're using that little exponent of 2 of the lengths of the two legs is equal to the square of the length of what is called the hypotenuse. So they have it over here that they show this, and I like this. The hypotenuse is going to be the longest part of your side of your triangle. So it's always going to be the one opposite of that right angle. So again, your hypotenuse is the longest part of your triangle. It's always going to be across from that right angle. That's going to be really important. And then the legs are the other sides. Okay, so those ones are considered your legs. So they show it in here, but I think the algebra version is a little better to explain first. So what they say is if I take the sum of A and B, but also if I square A, so I take A squared plus B squared, it should be the same as the hypotenuse, or C squared. So maybe you've already heard of this equation before because it's very popular. A squared plus B squared equals C squared. They also then show an example of that. Well, if I took 6 squared plus 8 squared, 6 squared is 36, 8 squared is 64. Well, 36 plus 64 does equal 100, which is 10 squared. So that's how they could figure out the different sides of this triangle. So we're going to take a look at a couple examples of this. So let's take a look at example 1 here, which says find the length of the hypotenuse. Oh, that's that longest side. Okay, so the longest side to the nearest hundredth. It means 2 decimal places. Okay, so the equation, and I'll write it down again, was a squared plus b squared equals c squared. Really what you're doing is you're adding up the 2 sides and squaring them, and then it should be the hypotenuse as your answer squared. So here's how I would set that up. In this case, this is my c, as you can see. 2 and 2 are my side lengths. So it doesn't matter what order. I would have 2 squared. Maybe we'll make this a. 2 squared plus, and then this is b. Doesn't matter. 2 squared equals c squared. Well, if I want to solve this out, I need to find 2 to square. 2 squared is 4. 2 squared is 4. I don't know what c squared is, so I can't solve that right now. But 4 plus 4 is 8. So c squared is 8, but we want to know what just c is. So we have to get rid of the square. So I'm going to just rewrite it as this. C squared equals 8. And if you remember when we were learning about square roots undo squares. So to undo this and get just c, I'm going to take the square root. That gets rid of this and I'm left with c. And then I have to figure out what is the square root of 8. This is where your calculator is going to come in handy, or if you can plug it up from the computer. Because they want me for 2 decimal places. So it was 2.828.427. It continues on, but if we want to round it to the nearest 2 decimal places, I'm going to have to look at the one right next to it here, which is going to mean I'm going to round up this 2 to a 3, so that I'd have 2.83 as roughly my answer for this. So that's why it comes in handy that we practiced not knowing, perfect squares here. All right, so the next one, they give it to me on a coordinate plane, and they make it a little challenging because they say that the coordinates are here, but the coordinates are at 3, 1, you got 0, 1, you've got 0, 5. But they also show how much of a distance this is, and it's kind of hard to see, but they say that the distance here is 4, and the distance here is 3. So again, we need to figure out what is this one, which is our c value. So we're going to have a squared plus b squared equals c squared. Well, we don't know what c squared is, so we're just going to leave it as c squared. And it doesn't matter if 4 is a or if 3 is a, so I'm just going to take 3 squared plus 4 squared. Again, doesn't matter which one's b as long as you're just using the other one. So 3 squared is 9, 4 squared is 16, c squared. Well, 9 plus 16 is 25, is c squared, but then we get to undo it by doing the square root. Hey, I know what the square root of 25 is. 25 is 5, so c equals 5. And so it also might end up becoming a perfect square and an easier answer to solve out. So then the side length for this one would be 5. And this is actually called a 3, 4, 5 triangle, which happens a lot in math. I just hit my water bottle. All right, so this time it says solve for the unknown side in the right triangle to the nearest 10th. So we're going to have 1 decimal place. And this time they give me b that I don't have. So here's my equation. A squared plus b squared equals c squared. Now I just have to determine is 9a or is 15a. So think about my square here. My square here, my right. This is showing me that right angle, and I always said the hypotenuse is right across from it. And so this is your hypotenuse, which is always your C value. So that's my C, and so 9 is going to be A. So I'm going to plug in 9 for A. I don't know what B is, but I do know what C is. Now I'm going to solve out my squares here. Well, 9 times 9 is 81. I don't know B squared. I actually don't know 15 squared off the top of my head. So I'm going to grab a calculator, which is 225. Well, I still have to solve for B squared here. So I have to use my understanding of algebra components to get B squared by itself. So I'm going to move over this 81. It's a positive 81, so I'm going to subtract it. Whatever I do to one side, I have to do to the other side. So now these cancel out. I'm left with B squared on this side. And then I'm going to take 225 minus 81, which gives me 144. And then I have to undo that square, so I'm going to square root it. Whatever I do to one side, I do to the other. And the square root of 144 is 12. And so you get a nice even number for this one. So using what we know about our squares and square roots, as well as knowing how to use those algebra components that we learned in a previous unit. And we've got one more problem. Alrighty, so this problem, a little more wordy, says Mark and Sarah start walking at the same point, but Mark walks 50 feet north, so he is going this way. This is Mark. While Sarah walks 75 feet east, so this is Sarah. How far apart are Mark and Sarah when they stop? So they want to know, how far away are they? So where's that distance from here to here? Mark and Sarah's distance from each other when they stop walking is equal to the hypotenuse of a right triangle. So as you notice, they already had it diagrammed out. They're saying this is C. So we're going to use our formula of A squared plus B squared equals C squared. I don't know what C squared is, but I can either make A 50 or AB. Maybe we'll make A 50. 50 squared plus, and then the other one was 75 squared. Now these are really big numbers, and I'm going to tell you I don't know those ones off my head, so I'm going to do 50 times 50, which is 2,500, plus then what's 75 times 75? 5,625 equals C squared. So these ones, that's okay if you want to use a calculator. And then I'm going to add those two numbers up, which looks like I get 81,025 is my C squared. And then I just need to undo the square by square rooting. And then this is going to be a weird number. So again, I'm going to have to plug it into the calculator. I'm not expecting you to just know this. So square root of 8125. Ooh, that's an interesting number. So I get C equals, did they tell me I needed to round it? How far away when they step? They didn't tell me how to round, but let's go to the second decimal place. So originally what I got was 90.1387818. Let's keep the first two decimals and we'll just round up to there. So I look at the one right next to it, which is an 8, so it means I'm going to increase this 3 to a 4, and so I'd have 90.14 feet away, roughly. They are away from each other. All right. We will continue working on problems like this as we continue on today. Just let me know if you've got questions.